uh, this is Unit 2 MCQ test corrections. I got number 2 wrong because since I know friction is equal to centripetal force in this problem, the centripetal force is mv squared over r. So I just plugged in the values, which is 0.6 squared divided by 0.1. This is wrong because it equals 7.2, which is D, which is wrong because this is mass and 2 newtons is not mass, it's in kilograms, so you divide it. You divide 2 by gravity, which is 10, and that should give you 0.2 kilograms, which if you plug it back into here, it should equal to 0.72 newtons, which is the answer. So I got it wrong because I didn't convert the units. For this problem, I didn't read the question properly, and because it says it's coming to a stop with constant acceleration, and I didn't read it properly because it says the mass is always hanging at equilibrium. So this means, and during the first part is the elevator moving downward at constant speed, which means the length is just constant, and since the elevator is gradually coming to stop with constant acceleration, that means acceleration is pointing upwards, and so it's constantly accelerating upward. The force of the spring needs to be greater than it in order for it to still maintain in order for a mass to hang in equilibrium, which means the answer B is constant and then it is greater than x1. For this problem, I don't know why I chose is equal to G, because since there's no friction, and in order for the block for the block to go around the loop, it says it needs to have greater speed than G, because if it has equal, the block will just the block will just wouldn't be able to go through. So which is why the block needs to have greater speed than gravity at the top of the loop. For this question, so I thought that the magnitudes are different if the mass are different because of gravity, but this is the force that they are exerting on each other is normal force, and normal force is, and since the blocks are the normal force that each block exerts on each other is equal in magnitude because of Newton's third law, which is that every action does an equal reaction, which means that the blocks are exerting, the two magnitudes that the blocks are exerting are always equal in each stack because the mass doesn't matter.